Hey everyone, it's Ed, and in this video I want to show you how I'm going to program a autonomous routine for a simple robot with a two-wheel drive and a launcher motor. So what I want to do is program the robot to drive forward, turn, and then spin up a wheel to launch a game piece, and then drive forward again. And I'm going to do this in a way that lets you script out exactly what you want your robot to do and make it very easy to tweak and dial in. So with that said, let's get started.
Okay, to program the robot, what I'm going to recommend you do is connect over Wi-Fi to your actual robot. This makes it so we don't have to take a USB cable and plug one into our computer and one into the robot. So once you have that connected over Wi-Fi, go to 192.168.43.1:8080. You can go to that in your web browser of choice, hit enter, and now we're in the web interface for working with the robot. We're going to make an autonomous routine. So to do that, I'm going to create a new op mode. I'll call this Ed Drive Auto, and we'll keep this basic op mode selected there. We'll click OK. And now once again, we have a blank op mode. We have to make one modification here, which is get rid of this. In autonomous, we don't want to keep looping our code over and over and over again. We want to execute a series of instructions and then stop. Go to actuators, DC motor, and set up one of my motors to be inverted. What I'm going to do is I'm going to create a function that's under function, and we're going to drag this over here and say this is going to be a time drive. Next, I'll configure this, and rather than getting the inputs from the controller, we're going to have this bit of code ask for input. So we'll have it ask for how much forward. I'll drag this in here. I'll add another input for turn. I'll drag that there. And next I'll do one more input for time in seconds and drag this in there. Go to actuators, DC motor, left motor power. What is the left motor power? Will be math. The addition of, it'll be variable, forward, and variable, turn. I'll copy this with Control-C, Control-V. I'll paste that there and change this to right motor and change this to minus. Once we set these values, we want to tell the robot to keep those values for some amount of time. So I'm going to go to linear op mode. I'm going to call this sleep block. Plop it right there. How long are we going to sleep? We're going to sleep for time seconds. But you notice here, this is actually saying in milliseconds. Now, a millisecond is 1,000th of a second. So if we provide 1 here, it's going to sleep for 1,000th of a second. So we're going to multiply this with a multiply block. We're going to multiply the time seconds by 1,000. And if we actually would call this right now, what will happen is the left motor and the right motor will turn on with whatever they need to turn on with, and they'll actually keep going. And we don't want that. So the next step is to copy and paste that block there and remove that. And after we drive for however long we want to drive, we say, hey, turn the motors off. And that'll stop the robot from driving off into a wall. Now that we've built this block, we can actually use this in a bunch of places. So I can go to functions, and now we have a new block that is populated. This time drive is going to call this bit of code. And now I need to give it some numbers. So I can say math, number, number, number. And let's say I want to make the robot drive forward for 1 second. Let's go 0.25. So 25% speed for 1 second. One other thing that's very important to do here is we're going to change this from a teleop to an autonomous routine. And then we can actually say, when this finishes, go ahead and run our other code there. And that'll make it so that when we select our programs, they show up in the correct spot on the driver hub. We'll click save, and we'll go ahead and test that.
Now to select our code for autonomous, we hit this left drop down here. You can see my code that we just wrote is here. And then we click init. And when we click start, we should see that robot move. So let me move this out of the way. Click start. See our robot move forward for a quarter of a second and then stopped. And that's perfect. Because we've set this up as a function we can call over and over and over again, we can now execute a series of movements for the robot to follow.
So now that we've seen that work, let's demonstrate copying this block and pasting it. And let's say I want the robot to turn 90 degrees or so. So I'll change forward to 0. I'll set turn to, I don't know, maybe 0.5. and make it turn for a second. And then maybe after that, we make it drive forward for another little bit. The power of this is we're basically scripting out what we want the robot to do, and the robot will do each step in sequence and then stop. And you can build a whole autonomous routine that, for example, leaves a zone, drives over to a spot, launches a game piece, turns, goes and picks up another game piece, and you can do that all with this technique. We'll go ahead and test this, and we'll see what that does.
It's very important when we're running autonomous to always start the robot at the same location so that we can compare our auto across different runs. So once again, I'll hit my drop down for auto. I'll hit init, and then I'll hit start. We see forward, turn, forward. A little more than 90 degrees here. This is probably 135 degrees. So if I want it to turn less, I have two options. I can make it turn slower, or I can make it turn for less time. I generally favor turning slower. However, in autonomous, you only have 30 seconds. So if you have a really complicated auto routine, you may need to keep that in mind. But those are my options. If I need it to drive further or less far, I can play with the speed it drives at, or I can play with how fast it drives. So let's go ahead and see if we can tweak that in to be closer to a 90-degree turn. And rather than turning this way, I'll make it turn the opposite way.
So to make those changes, what I'll do is I'll change this from 0.5 to 0.3. And this is kind of guess and check.
Okay, I've adjusted the turn parameters, so let's see how this goes. I click init and I click start. Okay, so it went the right direction this time, but it still didn't quite turn far enough, but I think you get the idea here.
Now, one other thing I'll do is I'll go to DC motor and I'll grab a power block here. And let's say after I turn, I want to turn on my launcher for some amount of time. Set my launcher power to 1. I can grab another sleep block here. And let's say we turn it on for a second. And then after that, we can copy paste and turn it off. And we can save that. But we can also do the same thing we did earlier and say, hey, let's make that a function. Say we can make this a timed launch. And I can go settings. I can go launch speed, drop that in there. I can go for time in seconds, drop that in there. And this time what I'll do is I'll take these 3 blocks, plop them in there, and then we'll go to variables, sleep for time seconds, variables, launch speed, because I can't spell apparently, but that's fine. Drop that in there. And now I can go back to functions, and you see we have a new function here where we again can say launch speed to be, let's say 1, and launch time to be 1. Ah, that's right. I actually have to multiply my time by 1,000, just like I did up here, because otherwise that would run for 1 millisecond and we wouldn't see anything. And what I see here is I actually forgot to turn off the motor when I was done. So let's make that change. So let's see what happens next.
Again, I select my code, init, and this one's for the money. Let's go. Okay. That was pretty much everything I wanted. It drove forward, it turned, I heard the motor turn on for a moment, and then it drove forward again. Still not hitting quite 90, but really all of this is a matter of finding the right amount of drive time and speed for that to work. So I think I'm going to call it good there. I've demonstrated how to make the robot drive, how to trigger some other actions on the robot, and do that in a way that lets you script out your whole autonomous routine. All right, so I'm pretty happy with how that turned out. What we ended up with was code that was very easy to script out what we wanted the robot to do, and it executed those instructions. Here it's mostly a matter of adding as many instructions as you need to complete whatever you wanted to complete in autonomous, and trying it out a bunch of times on a practice field or the real field, and dialing in those values until you get it to perform the way you want. So that said, I hope this was a good example of how to program a simple autonomous routine for your robot. If there's anything else you want to see me cover in the future, as always, let me know and I'll see what I can do. Till then, take care.